The resistance of various things can change under various circumstances, and as usual, the quickest and easiest way to analyse this sort of thing is graphically. So we're going to be plotting some graphs for different types of component in this video. We're going to be plotting graphs of current against potential difference, sometimes called an IV graph, because you might remember that we can actually calculate resistance by doing potential difference divided by current. But if we look at this graph, the gradient is going to be the current divided by the potential difference. So it's actually the inverse of the resistance. What that means is the gradient of these graphs is 1 over the resistance. Don't worry too much about what that means mathematically. All you really need to know is that the steeper the gradient of these graphs, the lower the resistance, and the shallower the gradient, the higher the resistance. Okay, so now we know what we're looking at. Let's dive in and look at a few different components. We're going to start off with the simplest type of component, something called an ohmic resistor. Ohmic resistors are things that have a constant resistance, so that means a constant gradient. It's going to be a straight line like this. Another way of saying that is that the current and the potential difference are directly proportional. You'll notice that when we apply a negative potential difference, we get a negative current. All that means is that the current is going through the component in the opposite direction, and the behaviour is exactly the same as when it's going the other direction. So these components don't really care which way round in the circuit they're connected. They don't care which way the current is going. Now, different ohmic resistors might have different resistances. So if we plotted two different ohmic resistors on the same graph like this, you'll notice that they have slightly different gradients. The steeper line represents an ohmic resistor with a slightly lower resistance than the shallower line. An important note is that ohmic resistors only work at a constant temperature. So the temperature of these things has to stay the same. Another common type of component that we can analyse is a filament bulb. That's the old-fashioned light bulbs that glow by making a piece of wire inside the glass bulb really hot and start to glow. These behave slightly differently. This is what their IV graph looks like. You'll notice that as we increase the potential difference, the gradient gets shallower. So that means the resistance gets higher as we go to higher potential differences. The reason for that is the more energy we put into them, the hotter they will get. And you'll remember that hotter components have a higher resistance. So this makes sense. Now, again, we can see that when we apply a negative potential difference, we get exactly the same behaviour, just with current being negative as well. So again, the current can flow either way. It doesn't make a difference. And finally, another common component is an LED. These are sort of more modern lights that they can be found in loads of places. Little standby lights on the front of TVs, the flash on your phone camera is made of LEDs. We can even make light bulbs out of LEDs these days. And in fact, what I'm using to light this right now, these are LED lights. IV graphs for LEDs look a little bit different now. The most noticeable thing here is that when we have a negative potential difference, we actually have zero current. So the current can't flow through backwards. LEDs will only allow current to pass through one way. So if we apply a negative potential difference, we get no current. We get a flat line, which means it's got a huge resistance. I mean, technically it means it's got infinite resistance when you apply a negative potential difference. But if we look at a positive potential difference, we get a much more familiar behaviour. You can see that beyond this little threshold, the current does start to increase proportionally to the potential difference. So we've got a constant resistance once we get above a certain potential difference. These are the most common types of component when it comes to IV graphs and resistance, so make sure you're familiar with them and you know how to describe what's going on.